Alright, this video is going to cover inequalities, specifically whenever you change the sign. So when you multiply or divide an inequality by a negative number, it flips the sign. So the reason I'm actually making a video on this was because I could never find a satisfying answer to why we flip the sign. And when I was trying to find the reason we flip the sign, all the answers I came across were either too vague or not satisfying enough. So hopefully this video can answer the question of why we flip the sign, because they never really taught this stuff in school, or at least in my school. I don't know how it's like in the rest of the world, but hopefully this will be something new. So what I really mean by this is, if you have an inequality where, let's say, a number is greater than another number, if a is greater than b, then negative a is less than negative b. And you can do that through multiplying or dividing by negative 1. For example, if you have 5 is greater than 4, then let's say you multiply by negative 1, then minus 5 will be less than negative 4. And so, well, to really explain this, we need to think about the nature of negative numbers. But first, let's talk about positive numbers. So with a positive number, we can split it between its sign and its magnitude. So with positive numbers, a bigger number would mean a greater magnitude, right? So a positive number with a greater magnitude is going to be a bigger number. For example, 6 is going to be greater than 4, if we're talking about positive numbers. But if we think about negative numbers, then actually the greater the magnitude, then the smaller the number it actually is. So it's kind of the opposite of how positive numbers act. And that's because of the minus sign. So that brings us on to what we are really doing. When multiplying and dividing by a negative number, we first multiply or divide by the magnitude and then by minus 1. For example, if we wish to divide by minus 3, then if 27 is greater than 9, which it is, and we want to divide by a negative 3, we would first divide by 3, so it'd be 9 is greater than 3, and then we divide by negative 1, which flips the inequality. And that brings us on to the 3 different cases for an inequality. So if we have a is greater than b, then either a is positive and b is negative, both are positive, or both are negative. We can't have b as positive and a as negative, because then if b was positive and a is negative, then b would have to be greater than a. But we're given that a is greater than b, so that can't be a case. So let's think about our first case where a is positive and b is negative. If we multiply or divide the inequality by a negative number, then a will turn negative and b will turn positive. And as we previously said, a positive number always has to be greater than a negative number, so we have to flip the inequality sign to account for that. The second case is where both are positive, and we sort of dealt with that case in the previous example. Here we're given that 27 is greater than 9, and then we divide both sides by a negative number, and we flip the sign when we divide by negative 1, right? Because that adds the negative sign, and because of how negative numbers are, we have to flip the inequality sign to account for that. And lastly, our third and final case is where both of the numbers are negative. So if a is greater than b and both are negative, that means that a needs to have a lower magnitude than b, right? Because as we previously stated, that's how negative numbers are. So when we divide and multiply by a negative number then, we turn both of these numbers into a positive number. But we've already established that a has a lower magnitude than b, so we need to flip the sign to account for that. And so this is one way to explain why we flip the sign when we multiply or divide by a negative number. But this explanation is a bit roundabout in that it doesn't cover all the corners. And what I mean by that is that there is a problem. If we have a is greater than b, and then we take log base c of both sides, where c is between 0 and 1, that actually flips the inequality sign. And here's an example. If we have 25 is greater than 5, and we take log base 0.5 of both sides, then you can see how that flips the sign. So really, what's going on here? we aren't really dividing by a negative number explicitly here. I mean, maybe we are if you try and convince yourself using some log laws and change of base, but I think I have a better explanation as to why this happens. And for that, we need to extend our rule. So if you've done any research on this on your own, then you might have come across some people saying that applying a decreasing function changes the inequality sign. And while that is true, let's go into further detail on what this definition really means. So a decreasing function is when the gradient or slope is less than 0, or negative, and an example of a decreasing function might be negative x cubed. You can see how the graph is constantly just going downwards. So this is what you might call a strictly decreasing function, whereas a graph of f of x squared, this is only decreasing when x is less than 0. So let's think back to the function we applied when multiplying and dividing by a negative number. Well, what we really did then was add a negative sign and scale it, right? So the function might look something like this, where f of x is equal to negative ax, where a is greater than 0. We can't have a as less than 0 because then the negatives would cancel out, and then we'd no longer be multiplying or dividing by a negative number. So now let's think about what this function actually looks like. So if a is greater than 0, then the function would look something like this. It wouldn't look exactly like this. This is just the case where a is 1. But you can see how the function would always be decreasing. And you can prove this with calculus as well. If you just find the first derivative, you can see how that function is always going to be negative. So now let's think about the properties of decreasing functions. So the greater the input, then the smaller the output. And that's because the function is always going downwards, right? So the further along you go towards the right of the x-axis, then the smaller the output. So if you think about an inequality where a is greater than b, then when you apply a decreasing function on both sides, that will change the inequality sign because of the properties of decreasing functions. So let's think back to the logarithm function. So using our definition of decreasing functions, we can actually sort of explain why the inequality sign flips. And that's because if you have log base c of x, then the function is always decreasing. Here I've sketched out the function of log base 0.5 of x, but you're just going to have to trust me that if c is between 0 and 1, then the logarithm function is always decreasing. And maybe there's a proof of this, but I haven't done any research on that, so yeah. Now let's consider some more functions. So if we have the function 1 over x, you can see how this function is actually strictly decreasing. It's always going down, which means that if you have an inequality where a is greater than b, and you wanted to do the reciprocal of both of them, then you'd actually have to flip the inequality sign. And that's because 1 over x is strictly decreasing. So that's it for the video. Hopefully you learned something new, because I definitely didn't know this before I made this video. And yeah, I did want to go over like other things about inequalities, because there are a couple of things that I didn't cover in this video. But I don't know. I don't think they're too important.